Assalamualaikum and good day. Today we are going to look at how to calculate the center of mass for a system containing a large numbers of particles. So the particle separation is very small. So we consider that the object have a continuous mass distribution. So what we do is we divide the object into small elements, and each element has a mass of delta m delta mi with coordinates xi, yi, and zi. So if we want to calculate the x coordinate of the center of mass, is approximately written as xcm, the summations of xi delta mi over the total mass m. So we use the similar expression for ycm and zcm. Okay, so what we do is we replace the sum by an integral. The integration method help us to do the summation. So we write x cm equals to 1 over m. M stands for the total mass of the system, and also the integrations of x dm. And we also write the similar equation for ycm and zcm, which is ycm equals to 1 over m, the integrations of y dm, and zcm equals to 1 over m, integrations of z dm. If we want to write it in the vector position, so we can write it as rcm equals to 1 over m, the integrations of r dm. If we have irregularly shaped object, for example, the wrench in the figure, what we do is first we hang the object in the horizontal position until the object stop oscillating, okay, or stop rotating, and we mark the line as AB. Then we hang the object in the vertical position and we mark the line as C and D. So the intersection between the line AB and CD is the location where we have the center of mass or the center of gravity of the object. Okay, let's look at example. A system consists of 3 particles located as shown in the figure below. Okay, find the center of mass of the system. Okay, let's say that this is the locations of the center of mass, and we have 3 particles. Particles 1, mass m1, particle 2 m2, and particle 3 m3. So particle 1 is a distant 1 from the axis. Particle 2 is a distant 2 meter from the axis, and particle 3 is 2 meter from the axis. So we use the formula to calculate the center of mass for x cm. So we use the formula where we do the summations of m1 x1 plus m2 x2 plus m3 x3. Then we total up all the mass of all the particles. We take m1 plus m2 plus m3. So we substitute the value, then we got x, center of mass for x coordinate is 0.75 meter. Okay, we do the same for ycm, where we take y1, y2, and y3, which is the vertical distance from the particles to the axis. So for particle 1 and particle 2, it's 0 because they didn't have any distance from the y-axis. Only particle 3 has a distance which is 2 meters from the y-axis. So for center of mass in y coordinate, we got 1 meter. So in vector position, we can write RCM equals to XCMI plus YCMJ, and it's equals to 0.75I plus 1J meter. Okay, that is if we only have 3 particles in the system. Now let's look at the example where we have large numbers of particles, and these particles is aligned in a line. So you are asked to find the center of mass for this particle, okay, and assuming that the rod has a uniform mass per unit length. Secondly, you are also asked to find the center of mass of the system if the rod is non-uniform. It means that the lambda is not the same at any part of the rod, but it is changing as a function of lambda equals to alpha x. So let's look at the first uh, questions, where we consider that the rod has a uniform mass per unit length. So what we do is we divide the system into small elements. Each element has a mass dm, where dm is equals to lambda dx. Lambda is the linear mass density. Okay. And this dm has a length dx, and it is a distance x from the axis. Okay, so what we do is we use the formula where we have lambda equals to dm per dx. So from there we find the dm, where dm equals to lambda dx. We substitute into the integration formula. So xdm equals to 1 over m xdm, where dm we replace with lambda dx. Okay, and we integrate it from one end to the other end of the rod, where L is the length of the rod. So you substitute uh, sorry lambda, and m is a constant value, so you can put it outside the integration. You integrate x, so we got x squared over 2, and we substitute x with L and 0. Finally, we have lambda L squared over 2m. Okay, but if we look at the total or the entire rod, lambda equals to the total m over total L. You substitute lambda into this equation, so we get m over L. Then finally, we have the center of mass of the rod, which is located at the center of the rod. So it is L over 2. That is for the first case. For the second question, where the lambda is not constant, where lambda is given by the functions alpha x, so we substitute into the uh, equation, where lambda we replace with alpha x, and we take out alpha because alpha is constant value, so we just integrate x squared, so we got x3 over 3, and we got the xcm is at alpha L to the power of 3 over 3m. Okay. Then what we do is, since x equals to 1 over m xdm, so you bring m over here, okay, and bring x over here. We just integrate tm. Okay, if we take the entire rod, okay, x cancel, so we have m dm. So m here can be replaced with alpha L squared over 2. You substitute into this equation, you will get that the center of mass for the rod is 2/3 of the length of the rod, which is 2 over 3 L. That is for if lambda is not constant. Next example. Okay. We have an object of mass m is in the shape of right triangle whose dimensions are shown in the figure. So you are asked to locate the coordinates of the center of mass, assuming the object has a uniform mass per unit area. So what we do is we divide the object into small elements. Each of the element has the mass dm, and the length y. So what we do is we sum up all the area of the small element, okay, and we will find the center of mass for this shape. So what we do is, to find the dm is, we find the total mass of the object, divide with the total area of the object, and times the area of the strip. So we write in mathematical operation. So m is the mass of total object. Total area of the object is 1 over 2 times base and times height. And the area of the strip is y dx. So we write it as 2m over ab and then y dx. Okay. Then we substitute into the center of mass equation. So we put dm here as 2m over ab y dx, and we integrate from 0 to a. Okay, from 0 to a. So we got the relationship between x and a is where we take x over a equals to y over b, and we got the expression y equals to b over a x. Okay. Then we substitute into y here. Okay, then we do the integration for x squared, because 2 and a squared are constants, so we put it outside. Okay, and then we integrate, we got 2/3 a. So it means that the x coordinate for center of mass is located at 2/3 of a, and for y, you do the same, you will get it is located at 1 over 3 b. That is for if we take the small element is divided into a vertical area. If you take the small element as the horizontal area, you do the same method. Okay, so our dm is 2m over ab x dy. Okay, and we do the same, we take x over a and we take y over b, and we take the expression for x, we substitute the expression for x into this equation, and you will find the x coordinates for center of mass, okay, which is measured 2/3 from the length of b, which is somewhere here, and you do the same for y cm. Thank you very much.